the square root property. We'll be discussing the square root property in this video, but first let's just talk about square roots. Square root of b is a because a squared is b. So if we look at plugging in instead of the b, if we plug in that a squared, then we would have square root of a squared. And something raised to the second power and taking the square root of it are opposite operations. They undo one another. So you can think about it as the squared and the square root undoing each other, and you're just left with a. So if we look at 25 and we want to take the square root of it, we can think of it as 5 squared, and then we can consider that the squared and the square root undo each other, and we're just left with a 5. You can also look at the square root of 9 that way. You can think what number squared equals 9, and we know 3 squared is 9, so the square root of 9 is going to be just 3. So whatever number is here is something that if we square it, we would get the radicand, which is this number under the radical there. Since 3 squared is 9, then the square root of 9 is 3, opposite operations. Now you do need to be careful if you have the square root of x squared plus 9. That is not the square root of x plus 3. And we'll get into some more of that later, but I just want you to notice if there's an addition underneath the radical or in the radicand, then we can't simply write it as the sum of the two square roots. It only works when we have numbers that are being multiplied. Okay, so taking the square root is the inverse of squaring, or the opposite of squaring. Taking a square root undoes the square, and vice versa. When we're working with quadratics, sometimes it's the easiest method for us to use to solve for x by using the square root property. And that's what we are wanting to talk about here. The square root property is a method that involves taking the square root of both sides of the equation to help you solve for the unknown value. To make the process as simple as we can, we put the perfect square just on one side by itself, so that when we take the square root, we're only taking the square root of something that's a perfect square, and then we use the square root on the other side as well. So let's take a look at an example. If I have x squared equals 16, that one's set up already for me. All I need to do is take the square root on both sides, and the square root of x squared, remember we're squaring and taking the square root of just a single thing, and they undo each other. And so I'll have x equals, and then the square root of 16. 16 is a perfect square, and 4 times 4 is 16, so the square root of 16 is 4. So x is 4. And what that means is if I plug it back into that original equation, it's going to be a true statement. So let's try that out. We'll do a check, and that is with x equals 4 because we believe that's our solution. So we'll plug that in instead of the x, and we want to see if we get 16. And you may be able to see it already, but I'm just going to go ahead and write it out for you. X, instead of the x, I put the 4. 4 squared is 16, which is equal to 16. And I was checking there, so I'll put a little question mark and then a check mark at the end to show that it's true. Now, we might remember that there's another way that we can find a number squared to equal 16, and that's if we have a negative 4 and square it. That'll also be equal to 16, because negative 4 times negative 4 is a positive 16. So that would also be a solution. So in order for us to take that into account, when we take the square root of both sides of an equation, we have to write down plus or minus on one side of our equation, just so that we'll end up with the 4, and then also our second solution, which was negative 4. So for this one, we would have a solution of positive or negative 4, and we take care of that by putting plus or minus on the side with our square root of our number. Let's take another look, or look at another problem. I have negative x squared plus 25 on the right, and I have 0 on the left. I'd love to get it back into the same form that I had for number 1, and it looks like I can if I just add x squared to both sides. And when I do that, I have x squared equals, and then the x squareds here cancel because they have opposite signs. I have x squared equals 25. Now I can take the square root of both sides. This time I'm going to remember to do the plus or minus on one side so that I can get both of my solutions right away. So I'll put the plus or minus on the right hand side, and on the left I can see my squared and my square root undo each other, and I'm left with just an x on the left, and 25 is a perfect square, and the square root of 25 is that number that you multiply by itself to get 25, and that number is 5, because 5 times 5 is 25, so the square root of 25 is 5. So when I write that down, remember I have that plus or minus, which means I have two answers. One of them is x equals 5, and one of them is x equals a negative 5. So two answers to check: x equals 5 and x equals negative 5. And let's just verify that those work, and it's a very good practice to go back to your starting equation and use it to do your check so that you check all of your work, not just the very last piece of it.